Hello, students. Let me ask you something. Have you ever looked through a magnifying glass and suddenly felt like a detective solving mysteries? That's the magic of a convex lens. But have you also noticed how a peephole in your door makes visitors look smaller? That's a concave lens at work. Now, both of these are spherical lenses, but they behave very differently. Convex lenses are converging lenses. They pull light rays together, almost like friends huddling for a group photo. Concave lenses are diverging lenses. They push light rays apart, like classmates spreading out to avoid getting caught copying in an exam. Today, we are going to compare these two lenses step by step. By the end, you'll never confuse them again, whether you're in the lab with a glass lens or spotting how cameras and spectacles use them in real life. Alright, champs, let's play with the magic of convex lenses. Imagine light rays as a group of friends walking into a party. A convex lens is like the friendly host who brings everyone together in the middle. Yes, it converges rays to form images. Now, depending on where the object is placed, the image can be real or virtual. For example, when you put an object far away, the rays meet and give you a real image you can actually catch on a screen. But if the object is too close, the image appears on the same side as the object, a virtual image, just like the magnified letters you see through a magnifying glass. Here's the fun part: the image can change its size. Sometimes it's magnified like your face in a makeup mirror. Sometimes it's diminished like when you're far away in a photo, and sometimes it's exactly the same size. Convex lenses are full of surprises. And finally, images can be erect or inverted. If you place the object between the focus and the lens, the image is upright, great for reading tiny text. But place it farther, and the image flips upside down, which is why in old box cameras everything looked inverted on the screen first. So, convex lenses are like shapeshifters, real or virtual, big or small, upright or upside down, all depending on where you place the object. Now let's turn to the concave lens, the complete opposite personality of the convex one. If convex lenses are like the friendly host who pulls people together, concave lenses are like that friend who says, "Okay guys, spread out, give me space." They always diverge rays, pushing them apart. And here's something interesting: the images they form are always the same type: virtual, erect, and diminished. Think of a peephole on a door. No matter who is standing outside, tall or short, the image you see is always smaller, upright, and inside the lens. Where do these images appear? Always between the focus F and the optical center O. They never go wandering far like convex lens images. And most importantly, you can never catch a concave lens image on a screen. Why? Because concave lenses don't produce real images. The rays only seem to meet when extended backward. It's like a magic trick: you see the image, but you can't grab it on paper. So, concave lenses are predictable, always virtual, always upright, always smaller. That's why they're so useful in things like door viewers and certain spectacles. They shrink the world just enough to fit your eyes comfortably. Alright students, it's comparison time: convex versus concave. Let's see their key differences side by side. First, the convex lens. It can form both real images that can be caught on a screen and virtual images that only appear to the eye. The size of the image can vary, sometimes magnified, sometimes diminished, or sometimes the same size as the object. And the orientation? It may be inverted or erect, depending on where the object is placed. Convex lenses are versatile, they love variety. Now the concave lens. This one is much more consistent. It always forms virtual images. The images are always diminished, meaning smaller than the object. And they are always erect, upright, and never upside down. Concave lenses are like that steady friend who never changes their order at a restaurant, simple and reliable. A quick memory tip: convex lenses curve outward, concave lenses curve inward. Think of the word concave as caving in. In daily life, convex lenses are used in magnifying glasses, cameras, and microscopes where we need enlarged views. Concave lenses are used in peepholes and certain spectacles where a smaller, wider view is useful. So, convex is the adventurous lens with many possibilities, while concave is the dependable one, always giving the same type of image. Let's try a real-life style problem. A student uses a convex lens to project the image of a candle onto a screen. Now the big question: will the same trick work with a concave lens? Step 1. Convex lenses can create real, inverted images. And because they are real, they can be caught on a screen. That's why projectors use convex lenses to throw huge images on the wall for movies and presentations. Step 2. Concave lenses, however, are not so cooperative here. They only form virtual images, and virtual images cannot be projected. It's like trying to catch your reflection from a mirror on paper. No matter how hard you try, it won't appear. Step 3. So, the conclusion is clear. Only convex lenses can form visible images on a screen. Concave lenses simply can't do it. And here's the application: projectors in classrooms and cinemas use convex lenses, while spectacles for myopia, that is, for people who can't see distant objects clearly, use concave lenses. So next time you're watching a movie on a big screen, you'll know that a convex lens is secretly doing the hard work behind the scenes. Alright students, let's wrap it all up with a quick recap: the convex versus concave lens story. First, the convex lens. It's the flexible one. Depending on where the object is placed, it can give you images that are real or virtual, magnified or diminished, and erect or inverted. It's like a chameleon, always changing its style based on the situation. Now the concave lens. This one doesn't like surprises. Its images are always virtual, always upright, and always smaller. Simple, predictable, and easy to remember. When it comes to real-world uses, convex lenses shine in places where enlargement is needed. Think of cameras, microscopes, and projectors. Without convex lenses, your movies, scientific discoveries, and magnified views would not be possible. Concave lenses, on the other hand, are your everyday helpers. They sit quietly in spectacles for myopia and indoor viewers, letting you see a wide view or helping distant objects look clear. So, the big picture: convex lenses are versatile image makers, while concave lenses are reliable shrinkers. Together, they make vision science practical, useful, and pretty amazing in our daily lives.